All right, students, welcome back. This video is actually for 7-3, but in case you need the 7-2 bell work, this is 7-2 number 2. It's the one that goes with Boyle's Law. So hit pause, go through this, all right? Meet me down at 7-3. Okay, so today we're covering 7-3. Don't forget to put this in your table of contents. All right, 7-3 is about Boyle's Law, but first we're getting into what is called the empirical gas laws. Empirical, the word empirical, if you remember in the fall when we talked about it, these are simple gas laws. All right, so we're talking about the simple ones, and they are very simple. All right, so here we go. Boyle's law describes the relationship between pressure and volume, and it says that as pressure goes up, volume goes down. Or we talked about this in class. This is an indirect relationship, right? Or inverse, whatever you want to say. You could say it either way, right? So that means as the pressure goes up, the volume goes down. And we can think about that in terms of like squishing a balloon, right? Squishing a balloon. If we have a balloon that's fairly blown up, right? And we squish it, right? It's going to pop, right? But the volume goes down. We're increasing the pressure. So our formula here is very simple. All right. Most of the time when we use this formula, we're talking about two different pressures and two different volumes. So P1 V1 equals P2 V2. All right. So we have two pressures, two volumes. The only thing about this, the only requirement is that when you have two pressures, they have to be in the same unit. You can't have ATM and mmHg. You would have to convert one to the other. All right. V is the same way. Volume, most of the time you'll see it in like milliliters or liters, but they both have to be in the same thing. All right. So sometimes you might have to convert there. So let's take a little peek at this. Whew, that's a lot of words. All right. Take a little peek at our example here. Our first example says we have a sample of oxygen gas has a volume. Oh, that looks important. Volume of 150 milliliters. I'm going to label that with V1 because that was the first volume I saw. When it's pressure, ooh, look, pressure is 0.947. So that's P1. What volume? We're looking for volume. So that's probably going to be V2. And the gas be at 0.97 atm. That's P2 if the temperature remains constant, because that's the other requirement of Boyle's Law is we need the temperature to remain constant. Okay, so let's go ahead and write out what we know here to the side. P1 we know is 0.947 atm. V1 we know is 150 milliliters. P2, writing getting a little rough there, is 0.947. 987, let's try that again. 0.987 atm. And V2 is our question mark. So we're trying to figure out what this does. So let's take a quick peek. First off, our pressure's in the same unit. Yes. Our volume then is going to be in milliliters in our answer. All right. Now let's take a peek at this. So we've got 0.947 times 150 is equal to 0.987 times V2, right? Now, real quickly, is volume going to go up? So pressure went up, so that means volume's going to go down. So when we type this in, let's make sure we get that. Now, to solve this, remember we're trying to get V2 by itself, so we're going to divide each side. Maybe I should change colors there. Let's change colors. All right. We're going to divide each side by 0.987. That way we can isolate the V2. So V2 is going to be equal to 0.947 times 150 divided by 0.987. And we're going to plug it in our calculator just like that. 0.947 times 150 divided by 0.987. And we should get V2 is 143, and to keep two decimals, 0.92. And we said our label was going to be milliliters. And there we have it. Fairly simple, yes? Let's try another example. All right. If you need to pause and get it written down, you can definitely, absolutely do that. So let's see there. So it says pressure. So pressure exerted is, ooh, yeah, this one's a little tricky, right? The pressure exerted on 250 milliliters, that's a volume, right? Milliliters is volume, is increased. Here's P1, 0.428, that's P1, 2.724 P2, what will the final volume be? We're looking for volume. So we're looking for V2. All right, kind of like we were in the last one. So let's write down what we know. P1 is equal to 0.428 ATM. V1 is equal to 240 milliliters. P2 is equal to 0.724. And V2 is what we're looking for. That's our question mark. All right, so let's plug it in. Go ahead. So we're going to have 0.428 times 240 is equal to 0.724 times V2. All right, we're still going to solve here. So we'll solve by dividing each side by 0.724 to get V2 by itself, which is what we're looking for. So when we look at this, pressure is going from 0.428 to 0.724. That is increasing, right? So our volume should, you guessed it, decrease. So let's see what we get here. 0.428 times 240 and divide by 0.724. And we should get 141.88. And that's milliliters. All right. That look good? How do we feel about that? Yeah, it went down. That makes sense. Let's try one more example. What I would like you to do at this point, since we've done two of them, I would like you to hit pause, copy this down, and try to do this one on your own. I will still do it in just a couple of seconds, but I would like you to try this one on your own. We would try it on our own in class, right? Okay, awesome. Here we go. So, the volume is moved from 15 liters, beep, to 4.5 liters. That's V2. The initial pressure, P1. What is our new pressure? That's what we're looking for, P2. That was kind of just a scribble, wasn't it? All right, so here we go. V1 is equal to 15 liters. P1 is equal to 1.0 atmospheres, which is atmospheric pressure, right? Or regular pressure. All right, V2 is 4.5 liters. P2 is our question mark. We're ready to plug this in. Remember our formula, P1 V1 equals P2 V2. All right, we have P1 1.0 times 15 is equal to question mark or P2. I don't know why I put question mark there. Let's try P2. All right, times 4.5. Okay, I'm going to blow this up a little bit so we can see it better. Remember, we want to isolate the thing that we're looking for, so we're going to divide each side by 4.5 to get P2 by itself. P2 is equal to 1 times 15 divided by 4.5. So our volume is going down. So what should happen to our pressure? You guessed it, it should be going up. So 15 divided by 4.5. Is 3.33 larger than 1? Yes, yes, it is. So there we have it. All right, hope this helps. See you on the next one.